We would like to present our research work, The Effect of Stress State on the Adhesive Strength of a Glue Sandwich in Shear-Compression Testing. Modified epoxy materials are fairly often used as a coatings, substrates or interlayers. In this case, it is important to have a material with low susceptibility to long-term mechanical effects, including local, and to know the mode of failure. There are various approaches to estimating the surface properties of polymer coating. However, the standard procedure of mechanical testing are inapplicable to such specimens. In this case, one has to resort to alternative test methods. An indirect method for determining the material strength parameters proposed by Carnier has found wide application in material science and in industry. The method consists in that material strength is determined from diametral compression testing of cylindrical specimen by a load uniformly distribution along the generatrix. Such tests are in the scientific literature referred to a Brazilian disc, Brazil nut sandwich, or Brazilian test. One of the modifications of this method is the use of an interlayer along the diametrical plane and estimation of the process occurring therein. This work proposed to consider this method as an experimental method for estimating the effect of the stress state on the adhesive strength of a glue sandwich. A cylindrical specimen with interlayer of thickness h positioned along the meridional plane of symmetry is placed between flat parallel strikes, the specimen length being several times its diameter. Through these strikes, the specimen is lowered to failure. The stress state in the joint is controlled by the tilt angle theta. The main advantage of this test is the fact that by varying the tilt angle theta with the one experiment, we can obtain both pure shear and pure cleavage, or a combination of both. The aim of this work is to discuss the possibility of applying shear compression testing to studying ultimate adhesive properties of a glue sandwich under a complex stress state. The object of the study is the ATP2 glue. The paint and varnish compositions were solidified according to optimized conditions. The test specimens were glued together half-cylindrical, made of aluminum-magnesium alloy, with the interlayer line of the symmetry plane. The glue layer thickness for each specimen is found in Table 1. The testing was performed at 25 degrees with the use of a universal test machine. The specimens were mounted on the machine strikers at different orientation angles of the plane of the glue sandwich relative to the direction of compression. As is known, when angle 0 degrees, the destruction of the glue sandwich occurs by cleavage. Therefore, in order to reveal the mechanism of shear-induced adhesive failure under the effect of normal compressive stress, the testing was performed at angles greater than 9 degrees. The loading diagrams align up to the failure load, and there were no yield plate and load decrease, this being indicative of the elastic deformation behavior of the glue layer. In all the diagrams were small steps and pulsation, which must be due to the formation of micro damage in the interlayer. The specimen fracture occurred along the glue-metal boundary, and it was associated with maximum loads recorded by the testing machine. No catastrophic failure, characteristic of brittle rupture from normal stresses, was noted. There was retarded separation of one specimen half from the other. The failure was adhesive in all cases, witnessed by the absence of glue on the symmetric areas of the surface of the specimen halves. According to the early result, it is here considered that resistance to adhesive failure depends on the stress traxiality factor, which depends on the stress normal to the area on glue metal boundary in the yield stress of the adhesive material. The specific surface energy of shear-induced adhesive failure was calculated as the ratio of multiplying the square of the tangential stress by thickness to the doubled elastic shear modulus. The dependent specific surface energy from stress factor was solved in the form of the exponent, the A0 and A1 empiric coefficients. Figure 3 shows a diagram of ultimate specific surface work of a shear-induced adhesive failure for the glue sandwich under study and the exponential dependence. It is obvious that under compressive normal stress, when stress traxiality factor less than 0, the value of the work spent on shear-induced adhesive failure increases rapidly. Based on Brazilian test results, the dependence of the specific surface energy of adhesive failure on the shear stress state under compressive normal stresses has been obtained for a sandwich composed of aluminum-magnesium alloy specimens glued together by ATP2 epoxy glue. Thank you for your attention.